Hello everyone, welcome to the classroom. Hello everyone, welcome to the classroom. If you can hear me clearly, can tap 1 in the chat box, okay? Happy New Year, everyone. Today is already our week 3, right? And it is still Teacher Jane that will learn together with all of us. Hello, welcome everyone. You can prepare a pencil, eraser, and a draft paper so that we can calculate together during the class. As for today's lesson, we will learn about countings together. It will be quite fun, I promise. Okay? Today is our week 3 and we will learn counting together, like counting cubes, counting 2D, 3D figures. This is a very, very common topic in the SMKC test. Welcome everyone. So we can see it is already 4:30. So let's start today's lesson. We can see that today is still Teacher Jane that will learn with all of us. And as for today's lesson, it is already our week 3. Cheer up everyone. Fighting, you did very well during the last 2 weeks. So today, Teacher Jane is also very looking forward to receiving your homework, okay? So let's have a look. And we can see this is Teacher Jane again. And as for today's lesson, it is already our week 3, right? You can see here. Oopsie, it is already February 6th. And next week, we will have our last lesson. And after that, we will also have mock test. Everyone, if you are interested, you can register the mock test that is after our next week weekly drills, and you can see, for example, on the February 20th, 25, we will prepare the mock test. And then don't forget to join our WhatsApp or WeChat group to prepare with all of our friends. Okay, so everyone, let's start. As for today's lesson, it is week 3, and we will learn counting problems together. For example, counting 2D shapes, counting 3D shapes, or counting some other tasks according to the question. Okay, so everyone, we can see. Firstly, we will learn counting shapes and the cubes together. Then we will learn enumeration. Someone may ask, this word is so long, I don't know what is the meaning. Or you can also remember it as listing method. That is, for example, if we have some cars, how can we list according to the question? Okay, so everyone, let's start. Warm up together. This is a real SMKC test question in 2017. And let's have a look. How many 5-pointed stars are there? Okay, so Teacher Jane just count. Haha, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. This is my answer. Do you agree? Yes or no? You can type in the chat box. No, definitely not, right? Everyone, you can see. Should we count everything? No, don't forget that. Here, how many 5-pointed stars are there, right? So we own 5-pointed stars. So for example, you can see 1, 2, 3, 4, 5. This star has 5 points, right? So we need to count this one. And then, do we need to count this? No, no need, right? So everyone, this time, let's count together. And then Teacher Jane just count randomly. Am I correct? Okay, so everyone, let's see. How should we count? A, in order. B, randomly, like from top to bottom and everywhere. I just count anyone that I see. No, cannot, right? We know that we always count in order from top to bottom, from left to right. So everyone, this time, let's count together. We can see that we need to count 5-pointed stars, right? So 1, 2, 3, 4. Anyone else? No more, right? Okay, good job. Good job, Sarah. Good job, everyone. So we can see that this time, what we need to do is just to find the target and count in order. Okay, so this time, let's have a look. This is a kangaroo question in 2020, question 7. Let's read the question together, everyone. Let's read it. Anna draws a picture of some shapes. Her picture contains 3 black triangles, and fewer than 4 squares, which could be Anna's picture. Okay, everyone, so I just feel like fewer than 4 squares, so that could be 1, 2, 3, or 0 squares. So I just feel like I figure out this one can just 2 squares. Am I correct? No, don't forget that there are 2 important information, right? One is that we need to have 3 black triangles. The other is that we need to have fewer than 4 squares. But fewer than, there could be so many possible ones. So probably we can just start from the 3 black triangles. So let's have a look. Which one has 3 black triangles? A, do we have 3 black triangles? 1, 2. Is this 3 black triangles? No, definitely not, right? So this one we cancel. And then how about the B? 1, 2, 3. 3 black triangles and fewer than 4 squares. So let's count. How many squares do we have? 1, 2, 3. 4. Okay, so is this our final answer? Yes or no? No, right? Fewer than. Fewer than means less than, smaller than, right? So this time we got equal to 4 squares. Can we say 4 is fewer than 4? No, definitely not, right? So cancel it. Okay, then let's have a look. How about the option C? We see 3 black triangles. So 1, 2, 3. Am I correct? No, seems not, right? This is right one. Okay, so we cancel it. And then how about the option D? Also no, right? You see only one black triangle. This one is white. And then how about the E? 3 triangles and fewer than 4 squares. 1, 2, 3. Okay, so actually you can type in the chat box A, B, or C. How many cubes are there? Type in your chat box. Okay, this time easy peasy, right? There are four cubes, but teacher Jane feel like, why? I only see this 1, 2. Oh, sorry, let me change another color. I only see 1, 2, 3, 3 cubes. Why you say there are 4 cubes? Okay, we know that the cubes cannot fly in the sky, right? So actually, below this tall one, there must be another one, right? It is hidden below. So actually, everyone, we can see that actually there are 4 cubes. So we can see, how can we count? Eddie says, probably we can count one by one. This one can, right? And April says, probably we can count by columns. Just column by column. Column means from top to down, right? So probably we can count by columns. And the doggy says, I want to count by layers. So everyone, let's see which one can be quite helpful. Let's try it together. Let's firstly think of, if we count one by one, it is quite easy for us to get wrong, right? So probably we can just count in a smarter way. So firstly, we can try count by columns. This is also called as the Boltzmann method. Okay, so you see, we can start from the shortest column first. And imagine that this is one hair. Imagine this is one hair. The hair is 1 centimeter long, 1 unit long. Okay, you see, it is 1. So we can label 1 on the top of the cube. And then this one also 1 and 1, right? And then I also label 1 on the top of this one. Can or cannot? Yes or no? Am I correct? No, definitely not, right? Because just now we say, we cannot just say the cube is flying in the sky. So what we need to do is just to label this one is 2 because it is 1 taller than the one in front. Okay, so this is 2, and then the one behind, we label 3 and 3, and then work forward to tower. So we can see what we need to do is just to count from the shortest one, and then label the number on the top. Then work forwards to the tallers and add up all the numbers to find the total. So everyone, this time let's count together. Let's calculate together, add them up. We can see this one should be 1 plus 1 plus 1 plus 2 plus 3 plus 3. So what is the final answer? Everyone type in your chat box. Okay, I got some answers already. That should be 11. Perfect. And then this time, just now we say we can count column by column, right? But this time, Teacher Jane will tell you another way. That is called as lazy guy method. For example, you can imagine, Teacher Jane is so lazy, so I just lay down on the ground. I just want to lay down and someone can carry me. So everyone, you see. But Teacher Jane, if imagine someone will carry Teacher Jane, then I must be on the top, right? So you see, we need to start from the top row. Okay, so this is Teacher Jane, everyone. This cube is Teacher Jane, the lazy guy. Okay, and then you see the step 2 is for each lower row. Then we count. Total cubes is the lazy cubes plus the working cubes. Let's see, what does it mean? Okay, everyone, you see, the layer below is carrying Teacher Jane, right? The lazy guy. So you see, But we cannot only counting the 3 that we can see, because you can see there must be a working cube that is carrying Teacher Jane, right? So we can see as for the lower layer, we can see there are 1 plus 4. And then what about the next layer? The most hardworking guy. Okay, so you see the last layer, we can see there are 9 cubes, right? Because the 4 ones are carrying the other layer. So we can see we can count column by column, and this time we can also think of the lazy guy method. That is, we can count layer by layer. Imagine that there are some working cubes that supporting the top ones, right? Okay, so everyone, we can see this is how can we solve the problem. And then what we need to do is just to add up the numbers to find the total. This time, just 1 plus 4 plus 9 equals 14. Good job, Sarah. Good job, Candice. Good job, everyone. Okay, so this time, let's move on and do some practice together. This is a SMKC test question from 2016, question 8. Which shape can we make with 10 cubes? Just now we learned a lot of method, right? So everyone, you can try Botman method. You can try the lazy guy method to try it. Okay, so everyone, let's have a look. As for the option A, probably we can try the Botman method. What about Botman method? Everyone, let's try it. Okay, so I label 1, 1, 1, 1, 1, and then this one, 2, 3. So after I add them up, what is the answer? That would be 10, right? Okay, so you see, I figure out, oh, this shape we can make by 10 cubes. And then let's move on. How about the option B? We try Botman method again, okay? So we start from the shortest one, and we can see this one, 1, 1, 1, 1, 1, then it's 2, 2, and 3. Okay, so let's have a look. This time we got how many? Seems like too many, right? This is 12. Okay, so seems cannot. Okay, everyone, we cancel it. Then let's have a look. How about the option C? This time we try Botman method again. 1, 1, 1, 1, 1, and then 3, 3. This time we got how many? Everyone, quickly calculate. Let's calculate. 11, right? Okay, everyone, 11. Okay, so this one cannot. Then what about option D? What about we try the lazy guy method? Let's count layer by layer. Try this time. So 1, 1, 1, 1. And as for the last layer, we got how many? 1, 2, 3, 4, 5, 6, 7. So this layer, we got 7. So this one, we got how many cubes in total? Any? Cannot. Then how about the last one? Do you want to try Botman or the lazy guy? What about we try the lazy guy again? So let's see. This layer, we got 1, 1. And then as for the working layer, there are many, right? So everyone, let's count together. 1, 2, 3, 4, 5, 6, 7, 8. Teacher Jane think the last layer got 8. Am I correct? Everyone, think about this. Am I correct? No, everyone, don't forget that Teacher Jane forgot this one below, right? So everyone, let's count again. As for the last layer, we know 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't forget that there is a working guy supporting the lazy guy, right? So you see, as for the last one, we got 11 cubes. So this one also wrong. The only correct answer should be A. Congratulations, everyone. Good job, Maggie. Good job. Okay, everyone. Then let's move on. Practice 3. Let's read the question together. The picture shows a group of building blocks. and a plan of these blocks. Some ink has dripped onto the plan. What is the sum of the numbers covered by the ink? Okay, can you guess? What is the meaning of the numbers? Here, 3, 4, 1. What does it mean? What is the meaning of the numbers? Everyone, what is the meaning of the numbers? Probably we can have a guess, right? Okay, everyone. Actually, the numbers here means that as for this column, we got how many cubes? For example, you can see the leftmost one, the 3 here. It means that as for this column, we got 1, 2, 3, right? And then as for this one, it means this one we got 1, and then this one we got 1. And you see this one means here we got 1 cube. So after this, we can make sure the numbers just means that as for each column, we got how many cubes? Then probably we can have a look. As for this ink, the ink part, what is the number here? Type in the chat box. Yeah, it means that as for this column, we got how many cubes vertically? Okay, so everyone, you can see between the column with 3 and 4 cubes, what is that column? Yeah, this one, right? So how many cubes are there? 2, good job. Because it is 1 cube shorter than the 3, right? Okay, so we can see this one we got 2. And then how about this one? Where is it? Let's do a vote, everyone. Let's do a vote. Which column is it for this inked part? Is it this column A, or this column B, or this column C? Let's do a vote. A, B, or C? Yeah, it is the column B, right? So everyone, we can have a look. It is the column B. And how many cubes are there in column B? 2, 3, 4? Yeah, 3, right? So we can see, as for this part, we got 3 cubes. Okay, so our task is to see what is the sum of the numbers covered by the ink. So what we need to do is just do 2 plus 3, we got C. Okay, everyone, if you can understand this, give me a big thumbs up. Okay, then everyone, let's move on here. Let's have a look. This is another thing that is about listing and enumeration that we just mentioned, right? So we can see this time our task is to list out all the 2-digit numbers that we can form using the cards below. So Teacher Jane is a little bit confused, everyone. I'm a little bit confused. How can we list? So enumeration just means that we need to list out all the possibilities one by one, right? So I think probably we can list 13, 32, 12, 21, 31, like this. Definitely no, everyone. It is so messy, right? Probably it's easy to miss any one of them, right? So we need to follow an order. So probably we can just listing from the small to the big one, right? So we can set a big boss, a king first. So we can try the 1 as the king. Then it can be followed by the queen. Who can be the queen? Can we list the 1 again? If we need to use 2 cards, and the question asked us cannot repeat, then what should we do? Yeah, we can get 12 and 13, right, with the big boss 1. Okay, so everyone, let's try some question together. This is a real test question. SMKC 2018, question 19. Think about the question. Can we repeat the digits? Let's read the question together, everyone. You see, how many different numbers greater than 10 and smaller than 25? This is really important, everyone. Greater than 10 and smaller than 25 with different digits can we make by using 2 of the digits. By using 2 of the digits 2, 0, 1, and 8. Think about the question. Can we repeat the digits? No, cannot, right? Because we need to use 2 of them, right? So everyone, probably I'll give you 30 seconds to try it first, then we'll discuss together. You can type your answer in the chat box, okay? How many different numbers that is greater than 10, smaller than 25, with different digits that we can make using 2 of the digits 2, 0, 1, and 8? So probably Teacher Jane just wanna start from the smallest. Just now you say you need to start from the smallest number, right? So Teacher Jane wanna start from 0 and write down 0, 0. This is my first answer. 0, 1, 0, 2, 0, 8. This is my answers. Am I correct? No, everyone, don't forget that 0 can never be the first number, right? Cannot be the first digit. So probably we need to try starting from 1. Okay, so I list down 10, and then 11, and then 12, and then 18. Am I correct? Yes or no? No, everyone. Firstly, let's have a look. The 10, am I correct? No, but why no? Can you tell me why? Exactly, because you see greater than 10, right? 10, can we say 10 is greater than 10? No, 10 is equals to digits, but we only have one card of 1, right? So this one cannot. And then let's have a look. 12, 18. This one can or cannot? Actually can. Okay, then let's try. The next smallest one should be start from digit 2, right? 2 as the 10th digit. So I list down 20, 21, 28. Am I correct? Yes or no? Type in the chat box. No, 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 no. Everyone, don't forget that the number is smaller than 25, right? So 28 can never. So our final answer will be 8. And here we don't even need to check whether start from 8, 80, 81 like this, right? Because 80 is already too big. Okay, so everyone, this is how can we solve the problem. You can set a king, big king, and then we start from the smallest to the biggest and try the numbers. Okay, so everyone, this time let's try another question. This time level up a little bit. You see, this is a P1 and P2 2023 question, and we can see digit 1, 1, 2, 3 are printed on 4 different cards. 3 cards are laid out to make a subtraction as shown in the picture. How many different results can be obtained? This question seems a little bit confusing. We got 4 digits. Digit 1, 1, 2, and 3. Printed on 4 different cards. 3 cards are laid out, right? So can we repeat, everyone? Think about the question. Can we repeat the cards? Yes or no? Type in our chat box. No, cannot, right? Because you can see, as for the question, we need to figure out 3 cards. 3 cards, right? So if we repeat the cards, imagine you just have 4 cards and you need to choose 3 cards. Can we repeat? No. Okay, so let's see. We need to use 3 cards to make subtraction as shown in the picture. How many different results can be obtained? So this time, probably we can also try starting from the smallest number, right? So here you can see, as for the big number, smaller number, who can be the big number? Probably we can try it one by one. So starting from the smallest number, how about the numbers starting with digit 2 as the 10th digit? 2 as the 10th digit. Yeah, we can have 21 and 23, right? Okay, how about the 3? Yeah, 31 and 32. So we can see, as for these two blanks, we can put the cards like this, right? The numbers below. So we can try to figure out how can we do the calculation and figure out how many different results can be obtained. Okay, so firstly, Teacher Jane used the 11. Firstly, we use the card 11. Everyone, let's list down together. Take out your pen and your paper. Let's do it together. So you see 11. So Teacher Jane is a little bit confused. Can we do 11 minus 1 that equals 10? No, because you see we only got two cards with number 1, right? So here we cannot use it repeatedly. So we need to start from 11 minus 2, and then you see what other cards do we have left? And 3, right? We already used 11, and then the next one, 11 minus 3 equals 8. And then, do we have other choices? No, seems not, right? So we need to choose the cards again. Just now, we also say we have 12. So 12 can do the minus. Okay, so this time, we choose the card 1 and 2 to be the 12. Then what cards can we minus? What cards do we have left? 1 and 3, right? So 12 minus 1 or 12 minus 3. Then we can get the final answer, right? Okay, so this time, do we have other cards that we can do the minus? Seems not. Okay, so probably we need to try the 13 this time. Okay, so this time we firstly choose the 13. And then what other cards can we do the minus? 1 and 2, right? So everyone, let's list down the workings together. The 13 can minus 1, and then the 13 can minus 2. Okay, so this is another working. And then let's try the next one. How about starting from 21? 21 can minus the 1, right? You see the 21, we use the card 2 and 1. So we can minus 1 and minus 3. So you see here we got the answer. And then how about if we start from the 23? 23 can minus what? Okay, so you see the 23, we already used the 2 and 3. So probably we can only minus 1, then we can get 22. But someone say, Teacher Jane, you see here we got another one. Can we do the minus this one? Actually, no need, right? Because you see here we only need to figure out the different results. 23 minus 1, they are just the same, right? Okay, so everyone, let's move on. How about 31? 31, we can do the minus. Okay, so you see this time we use the card 3 and 1, 31. So probably we can just minus the 1 and minus the 2, right? Okay, so this is how we solve the problem. And then don't forget, we still have the 32. So 32, okay, 32 can minus what? Yeah, can minus the 1, right? Do we need to minus the other one again? Seems no need, right? Okay, so here, Teacher Jane think, haha, I got 12 different results. Am I correct, everyone? Am I correct? No, everyone, because you see here, we got 9, 2 9s as the result, right? So everyone, let's list down together here. How many different results can be made? Okay, so firstly, we got a 9, we list here, and then an 8. Is it repeated? No. Okay, let's list in order. This is 8, the smallest one, and then the 9, and then 11. And then this 9 we listed already, so cancel it. And then how about the 12? Yes, we can have the 12. And then how about the 11? No, we have 11 already, so this one no need. And then how about the 20? Yes, 20 can, right? And then how about the 18? Yes, 18 also can. And then how about the 22? Yes, also can. The 22 also can, right? Okay, 22. And then the 30 can or cannot? Yeah, 30 can. And then 29 can. 31 also can, right? So here are the results that we can get. Okay, so everyone, this is how can we solve the problem. Okay, everyone, if you can understand this, give me a big thumbs up. Okay, so we can see there are only 10 different results. Okay, so this is all we learned today. In the first beginning, we learn about how can we count the shapes, how can we find the target, count in order. And then we also learn about how can we count the cubes. We learn about the Boltzmann method and the lazy guy method, right? And then you can see there's a lazy guy and there are working guys below that are supporting the lazy guys. And then we also learn the enumeration, that is how can we list in order. We just list out from the smallest to the biggest one. Okay, so everyone, this is all for today's lesson. Don't forget our WeChat or WhatsApp group and submit your homework into the group before Saturday 9 p.m. this week. Then you will have a little star, and if you finish all the 4 homework, you can get a present. Okay, so that is all for today's lesson. Everyone, hope you enjoy it. I'm looking forward to see you next week. Bye bye. Bye bye, everyone.